All right, here's a function. We're using s as the input for some reason. And the question is it even, is it odd, is it neither? Same thing. Anytime I'm determining whether something is even, odd, or neither, I first figure out f of negative x, although my input in this case is s, so I guess I'll figure out f of negative s. And here's my blueprint for f of s, so I can figure out f of negative s by just changing all of those s's into negative s's. And this is f of negative s, although I'd like to simplify that a little bit. Negative s to the fourth power is the same as s to the fourth power. Negative s squared is the same as s squared. And then I got plus 7. And note that what I have written right here is the exact same as f of s. So f of negative s equals f of s, which is exactly my criteria for being even. So this function right here is even. What about odd? Could it be even and odd? Yes, but not very likely. Only very trivial examples where that happens. But I don't think it's a good idea to just have that memorized. Instead, let's go through and actually test it. To test whether it were odd, the way I would do it is I would compare f of negative s, which I already figured out above was s to the fourth plus 3s squared plus 7. I'd compare that to the negative of f of s. And yes, I realize this is slightly different than the way your book does it. F of s is given to me right here. So the negative of this thing would be negative s to the fourth plus 3s squared plus 7. Which, if I want to get rid of the parentheses, I could distribute that negative through and get here. This is not the same as this. F of negative s does not equal the negative of f of s, so f is not odd. It is even, it's not odd. That's the end of this one.